All right, continuing with our examples here, part D on this find any vertical asymptotes problem. So here we have f of x is negative 3 e to the minus 2x over x minus 1. Okay, so I can automatically say that I must have a vertical asymptote at x equals 1, because that's going to make the denominator 0, and the numerator, which is negative 3 times e to the something is never 0. So I can say that there's a vertical asymptote at x equals 1, but again, while not really part of the problem here, let's dive a little deeper. The limit as x approaches 1 from the left of negative 3 e to the minus 2x over x minus 1. Let's see what happens here. All right, negative 3 goes to negative 3 as x goes to 1. E to the minus 2x goes to e to the minus 2 as x goes to 1, just putting 1 in. X minus 1 would go to 0, but we're approaching 1 from the left, so like 0.9 or so. So I'm actually going to get little negatives here. All right. So realize e to the minus 2 is just a constant. It's actually a positive constant. It's 1 over e squared. So I'm going to get negative 3 times a constant. So I get a constant on top. I get something going to 0 in the denominator. That gives me an infinity. Now let me do my signs. I have a negative 3 e to the minus 2 is a positive number, and then I have a negative in the denominator. So I have two negatives and a positive. Those negatives cancel. I get positive infinity. Let's go the other way, from the right. All right. Negative 3 still goes to negative 3. E to the minus 2x still goes to e to the minus 2. X minus 1 still goes to 0, but this time when I'm coming to 1 from the right, think like 1.1, I'm going to be left with little positive amounts. So now I have a numerator that's going to a constant and the denominator a non-zero constant, and the denominator that's going to 0, that's an infinity. Whoops. That's an infinity. Once again, that's an infinity. And I have a negative, a positive, and a positive. I have one negative. That's going to leave me negative infinity. So one of the reasons I did this problem is a lot of people think, they look for patterns and they think, oh, if I'm going to a number from the left, it must be negative infinity. If I go to a number from the right, it must be positive infinity. That's not true. That just happens in a lot of examples, but you have to work it out entirely. All right, let's look at some more examples, just finding the limit. So again, I'm going to do these like I was mentioning for the previous examples in the extra work. Limit as x approaches 2 from the right of x minus 3 over x minus 2. Okay, so as you approach 2, x minus 3 goes to, plug in 2 minus 3, negative 1. As you approach 2, x minus 2 goes to 0. Now, how does it go to 0? 2 from the right, so something like 2.1, that'll give me little bits of positive left over because I'm doing a little more than 2 minus 2. Okay, so again, overall I'm going to a non-zero constant on top. I'm going to 0 on the bottom. So that's an infinity. I have a negative and a positive, so it's negative infinity. All right, let's look at this one in B here. X approaches 3 from the left of x squared plus 2x minus 3 over x squared plus x minus 6. All right, so again, a first approach to any limit could be plugging it in. If I plug in 3 to the numerator, I get 9 plus oh wait, sorry, and this is a bit of a typo here, sorry. This should actually be approaching -3. I could do the limit approaching 3, but I want specifically what's going to happen when I push -3. So if I put in -3 into the numerator, 9 minus 6 is 3 minus 3, I get 0. And if I put in -3 to the denominator, 9 minus 3, 6 minus 6 is 0. So I've gotten this 0 over 0 situation. And what that means is I need to continue. Okay, I need to go further. So what I'm going to do is I'm going to factor. That should make things easier to see. Top factors to x plus 3, x minus 1. The bottom, x plus 3 over x minus 2. Okay, well, now we see the x plus 3 in numerator and denominator can be canceled. That was causing the 0 over 0. And now I go to -3 from the left of x plus, nope, sorry, that's gone, x minus 1 over x minus 2. Okay, so now analyze it by plugging in and see what happens. X goes to -3. -3 minus 1, this is -4. On the denominator, x minus 2, it's -3 minus 2, that's -5. Oh, okay. Well, we didn't get a 0 anywhere, so this is actually just -4 over -5, or in other words, 4 over 5. So this was not an infinite limit. I threw this in here just to remind you that you can't always be looking for it, and just because you're coming from one side doesn't mean you're going to get an infinite limit. All right, this was just your 0 over 0 situation in which a common factor canceled out, and you got a limit. All right, how about C here? Limit as x approaches 0 from the left of 1 plus 1 over x. Okay, let's break it down. As x approaches 0, 1 goes to 1. Now let's look at 1 over x itself. Okay, in the denominator, hold on, I don't want that much notation. In the denominator here, x is going to 0 from the left, because that's literally what it's doing. I don't need to do anything else. Okay, so this whole portion right here, this 1 over x, I've got a constant 1 on the top, and the bottom is going to 0 from the left. So this entire thing, this 1 over x, goes to an infinity, because it's going to a non-zero constant over 0, and it's going to be negative because the top, the numerator as 1 is positive, and the bottom is negative. Okay, so I've got something going to 1 plus something to go into negative infinity. Okay. Well, that 1 is going to get dominated. This thing is 1 plus negative a million, 1 plus negative a trillion. That's still going to go to negative infinity. Okay, let's look at this last one, which is a bit of a weird one, but okay. Limit as x approaches pi over 2 from the left of ln, absolute value of cosine x. Okay, so I need to figure out what's happening to cosine x as x approaches pi over 2 from the left. Okay, so let's think about cosine. All right, this is where you would have pi over 2. And as you're approaching pi over 2 from the left, you're approaching 0 in a positive way. So this is actually going to 0 as small positives. All right. So that, I mean, the positive nature is not going to matter there because I'm actually in absolute value. All right. So I have stuff in here going to 0, and then I have ln of that. Well, now I think the ln graph, this is why it's good to know these basic graphs, as I approach 0 in ln, this goes off to negative infinity. And that's why that would be negative infinity. Okay, those are some examples.